Hello students, welcome back to our YouTube channel. I am Mrs. Veena, Master Teacher of Chemistry. Today I am going to take up the topic from class 10 chemistry section. Topic which are going to start up today, that is lesson number 4, carbon and its compounds. This is an important chapter that clear your concepts and build strong fundamentals. Let's start our portion.
Let's study about the introduction section of the carbon and its compounds. The first point of this introduction section, carbon is an element. We already studied about the element in the class 9. And the second one, it is a non-metal. Third one, the symbol of the carbon is C. And the fourth one, the name of the carbon derived from the Latin word that is carbo. Carbo means what? Coal. This is because carbon is the main constant of this coal. The amount of carbon present in the earth crust and the atmosphere is very small. Next, fifth point, all living things, that is plants and animals, are made up of carbon compounds. Very important thing it is that plants and animals are made up of carbon compounds, that we call it as organic compounds. We already know that this lesson is also a carbon and its compounds lesson, that is organic chemistry part. How we can say that it is an organic chemistry? It is related to carbon and hydrogen. That's why we call it as organic chemistry. So all plants and animals, all living things that are made up of carbon compounds, that is known as organic compounds. And another sixth point, a large number of things we use in our daily life are made up of carbon compounds. Which are the daily life use things? That is, first one, our food materials like grains, sugar, tea, coffee, vegetable, fruits, pulses, etc. are carbon compounds. And this seventh one, it is the things we are making clothes. Which are the things, materials we are making clothes? That is cotton, silk, wool, nylon, polyester, that is used for making clothes. These are all made up of carbon compounds. And the eighth one, the fuels like, which are the fuels? That is wood, coal, kerosene, LPG. LPG means liquefied petroleum gas, natural gas. And next CNG. CNG means compressed natural gas, petrol and diesel, which are used for cooking food, and another one, it is running vehicles, are all carbon compounds. Another case, that is the daily life, that is paper, rubber, plastics, leather, drugs, dyes are also made up of carbon compounds. Now look at that. It is clear that these carbon elements plays an important role in the daily life. The second introduction part. Carbon always form covalent bonds. We already know that the atomic number of carbon is 6. And electronic configuration, how we can write electronic configuration? 2, 4. Look at this. It is clear that carbon has 4 electrons in the outermost shell. So look at this. Since this carbon atom has 4 electrons in the outermost shell, so it should either lose or gain 4 electrons to achieve inert gas configuration. What is the meaning of inert gas configuration? The outermost shell contains 8 electrons, that means octet structure. They have to fulfill the octet structure. So here now carbon atom is small due to these outermost electrons. These outermost electrons are strongly held by the nucleus. Look at this structure, nucleus, and the first shell contains 2 electrons and the second shell contains 4 electrons. So these outermost shell electrons are strongly held by the nucleus, so the size of the atom is very small. So it is not possible, look at in the case of outermost shell, it is not possible to remove 4 electrons from the carbon atom. And it is not possible to add 4 electrons, not possible to remove and add 4 electrons in the carbon atom to acquire this inert gas configuration. So what happens to these carbon atoms can achieve inert electron pair arrangement. They only share the electrons. So sharing means, we already studied sharing of electrons means they form covalent bond. Sharing of electrons are known as, so this carbon always shared the electron, sharing of electrons. So thus the carbon always forms covalent bond. Third introduction part, carbon is a tetravalent. We know that carbon atoms acquire 4 electrons to achieve this 8 electron energetic structure. Therefore, the valency of carbon is 4. So, electronic structure 2, 4. What is the valency? Valency of the carbon is 4. So, this 4 valency, how we represent carbon is, we call it as carbon is a tetravalent. Tetravalent means, tetra means 4. So, 4 tetravalent. Tetra 4, valent means valency. These 4 valencies of carbon are usually represented by putting 4 short lines on the symbol of the carbon. Look like this. On the symbol of the carbon, we are putting 4 short lines on the 4 side of this carbon atom. Next, versatile nature of the carbon. It's very important topic, versatile nature of the carbon. There are 2 versatile nature, that is, one, it is tetravalency. We already studied the tetravalency. Carbon that is shows the valency 4, so we call it as tetravalency. And second one, it is known as catenation. What is the meaning of catenation? Catenation means self-linking. The existence of this large number of these carbon atom, that is, they link with another by means of covalent bond in the form of long chain or branch chain or ring chain. Like these 3 forms, they can show that: long form, branch chain and ring chain. Long form means like this, carbon due to this tetravalency, carbon first form 1, 2, 3, 4 like this, and this carbon always show the valency 4. That's why we call it as tetravalent or tetravalency. So one bond is there, 1 and 2, 3, 4, and look at the second carbon, 1, 2, 3, 4, and third carbon 1, 2, 3, 4, fifth carbon 1, 2, 3, 4, like this they show the valency. Whatever chain they form, but they have to show the valency 4. And this is the long chain carbon, we can say long chain they form. That is a versatile nature, that is catenation. And branched chain, how they show the 1, 2, 3, they form like this, or branched, they form a branched form like this. And whatever branch, here also they have to satisfy the valency 4. Look at that, 1, 2, 3, 4, 4 side, 1, 2, 3, 4, and look at this carbon, 1, 2, 3 is there, the 4 like this, and here 1, 2, 3, 4, and here 1, 2, 3, 4, like this 4. This branched chain. And the third chain there shows the ring form. Ring form means like this, 1, 2, 3, 4, 5, 6, like this therefore. And here also they have to satisfy the valency 4. Look, this carbon show here it is 1, 2 and 3, 4, not inside, it shows outside, and 1, 2, 3, 4, and secondly look at this, 1, 2, 3, 4, here also 1, 2, 3, 4, like this therefore. So this is a ring form, ring chain form. So how can you define this catenation? The property of carbon atom due to which atom can join with another long chain carbon is called catenation. The property of carbon atom due to which atom can join with another form of long chain carbon atom is called catenation. And this existence of this carbon atom, large number of this carbon atom, the is that of the valency of the carbon is 4. Whatever resistance, the valency is 4. Due to this large valency of this 4, the large valency of 4, carbon atom can form covalent bond with number of carbon atoms as well as large number of other atoms also. Next topic, allotropes of carbon. How can you define as the allotropes of carbon? That means the various physical forms in which an element can exist. That is, various physical forms in which element can exist are called allotropes of an element. This carbon element exists 3 solid forms are called allotropes. That these are diamond, graphite, third one Buckminster fullerene. This, and in the case of diamond, diamond is an allotropic form of carbon. It is not a carbon, it is an allotropic form of carbon. Graphite also, and Buckminster fullerene is recently discovered. This Buckminster fullerene, these are the 3 physical forms. These are the allotropes of carbon. Now we are going to study the separate properties of diamond, graphite and Buckminster fullerene. First, diamond. In the case of diamond, it is a colorless substances. The first property, it is a colorless, transparent substances having extraordinary brilliance. So in the case of diamond, it is the first property is a colorless, transparent substances having extraordinary brilliance. Second, diamond is quite heavy and hard. Third one, in diamond, each carbon atom is bonded to, very important thing, in diamond each carbon atom is bonded to 4 other carbon atoms. Look at that, each carbon atom is bonded to 4 other carbon atoms forming 3-dimensional structure. Look like this, each carbon atom is bonded to 4 other carbon, and this also bonded to 4 other carbon like this. So they form 3-dimensional structure. That is why because of this structure, this diamond show extraordinary brilliance. And the fourth property, it does not conduct electricity, but gold conduct electricity, diamond does not conduct electricity. These are the properties of diamond. Second, graphite. Properties of graphite. First one, it is a grayish black opaque substances. In the case of diamond, we studied it is a colorless transparent substances, but here it is a grayish black opaque substances. We already seen that graphite in the pencil lead, that is made up of graphite. So that is, look at that, it is a grayish black opaque substances. First one. Second property, it is soft and slippery to touch. Soft and slippery. What about this diamond? Diamond, it is quite heavy and hard. Here it is soft and slippery to touch. And the third one, in graphite, carbon atoms are bonded to, in the case of diamond, we studied carbon atoms are bonded to 4 other carbon. Here carbon atom is bonded to 3 other carbon. Carbon atom is bonded to 3 other carbon. So we already studied carbon always satisfy the valency 4. So where is that another bond? So another bond, they form a double bond. They form a double bond like this. So in graphite, each carbon atom is bonded to 3 other carbon atoms in the same plane. That plane is same and forming a hexagonal array. Just like an hexagonal array they form. So look, one carbon atom is like this, and they form hexagonal array. Another carbon and 3 other carbon like this, and again carbon, and again they form another one like this hexagonal array, and this that one bond is a double bond, again they form like this. It forms in the same plane. Once again, the third property, in graphite, each carbon atom is bonded to 3 other carbon atom in the same plane, giving hexagonal array, and one of the bond is double bond. Here also one of the bond is double bond like this. So here this bond like 1 2 3. Here also 1 2 3 like hexagonal array. And fourth property, we already studied in the case of this diamond. Diamond does not conduct electricity, but here graphite conduct electricity. It conduct electricity. Just opposite of this diamond, it shows the property graphite. Third allotropic form of carbon, Buckminster fullerene. This Buckminster fullerene is a new allotropic form of carbon which has been discovered recently. Then the first one, Buckminster fullerene of the carbon, it is a cluster of these 60 carbon atoms joined together to form a spherical, that means C60. 60 carbon atoms are joined together to form a spherical molecules, that it is just like a football, otherwise we call it as buckyball, football or buckyball. This Buckminster fullerene is a dark solid at room temperature. And another case, it looked like a geodesic dome designed by the US architect, that is Buckminster Fuller. So this molecule was named as fullerene, short form, that is Buckminster fullerene, or simply we call it as fullerene.